Hey guys, welcome back to another video. So if you haven't already seen part 1, I do suggest you go and watch that first on this automatic transmission series. But in this part, I thought I'd take you back a few weeks because I've been busy for those past few weeks working hard on coding this little controller so that it can work perfectly in my car. So I thought we'd jump back in time now and have a look to see how I've got to this current point.
So, to begin with, I started to write a class for controlling the gearbox's 6 solenoids. To make things easier to understand, here is an image of the 722.6's gearbox's cross-section. This gearbox has a torque converter clutch, and clutches B1, K1, B2, K2, B3 and K3, as well as sprags F1 and F2. In total, these clutches and sprags allow the gearbox to have 5 forward gears and 2 reverse gears. In order to control the activation of these elements, my TCM has to control all 6 of the gearbox's solenoids. They are 1. Shift pressure solenoid. This solenoid controls the line pressure sent to the clutch packs in the gearbox during gear shifts. 2. Modulating pressure solenoid. This solenoid controls the overall pressure of the gearbox, keeping clutches and sprags applied after the gear shift. 3. Torque converter solenoid. This solenoid controls the clutch and the torque converter to enable lockup, increasing the efficiency of the vehicle. 4, 5 and 6, these are called shift solenoids. These solenoids are only activated during shifting and allow the pressure to flow from the shift pressure solenoid through the valve body of the gearbox in order to apply the correct clutch or brake for the target gear of the gearbox. For simplification going forward, I will be referring to the solenoids by their technical name Mercedes gave them. SPC, shift pressure solenoid, MPC, modulating pressure solenoid, TCC, torque converter solenoid, Y3, 1 to 2 and 4 to 5 shift solenoid, Y4, 3 to 4 shift solenoid, and Y5, 2 to 3 shift solenoid. Now, how does the gearbox actually change gears? This is where the magic of the hydraulic valve body comes in. Here is a diagram showing all the components and fluid lines in the hydraulic valve body of the gearbox. In this, you can see the fluid pump of the gearbox here, which provides line pressure to the gearbox via the input shaft of the gearbox. And here you can see the clutches of the gearbox. When these boxes here are white, it means no fluid is applied to the clutch, so it is off. At the bottom here you can see the torque converter clutch. Currently the gearbox is in park. Here is how things move in the valve body during and after shifts. Park to first gear, in first gear, first to second gear, second to third gear, third to fourth gear, fourth to fifth gear, and finally fifth gear. In order to downshift, the gearbox just does the exact same sequence in reverse like so. Note that unlike Mercedes' 7-speed gearbox, due to the way the gearbox's hydraulics works, it is impossible for this gearbox to skip gears during upshifting or downshifting, therefore every gear has to be applied sequentially. With that all out the way, back to the code. As usual, if you want to see the code for yourself, I'll leave a link in the description for all of it. I needed a way to control the solenoids in code using a PWM signal, so I created a solenoid class which has functions to read the current from each solenoid, as well as change the PWM frequency of each solenoid and its duty cycle. For current monitoring, I created a method which samples each ADC channel of the ESP32 hooked up to a current sense pin on my TCM, about 100 times per second using the I2S hardware on the ESP32's processor. This loop utilizes DMA data transfer so the I2S hardware can sample the ADC channel in the background without keeping the processor busy. Then, the processor simply has to take the results of these samples and calculate the mean voltage of the ADC channel, which in turn correlates to the current drawn by each solenoid. Every solenoid class checks on startup if everything is okay. If something is wrong, which could either be a hardware fault or a software error, the solenoid class sets an internal flag. When the ESP32 checks on startup if all the solenoids initialized correctly and sees one didn't, it will tell the main program running on it to enter limp home mode. Next, I set out to work about adding CAN bus support to my TCM, which is the main goal of this project. To start with, I set about writing a Python interpreter to pass my CAN matrix files from my old head unit project into C++. This parser generates a C++ class for every ECU described in the CAN data files, and struts for every CAN frame as well as correct enum definitions. I then passed both CAN matrix files for the EGS52 CAN networks and EGS53 CAN networks. Here are a couple examples of the script output files. Next, I decided to create an abstraction layer for interfacing with CAN. This way, both EGS52 and EGS53 versions of my TCM can use the exact same codebase for core logic such as gear shifting, and the CAN abstraction layer just acts as a translator between the two different CAN networks. Part of this abstraction layer comes from creating custom methods in an abstract C++ class for retrieving or setting certain values on the car's CAN network. Then, for testing with my car's CAN network, I wrote the implementation of this abstract class for EGS52 compatible vehicles. Here is an example of what that implementation looks like. And so, after many hours of programming, I finally had the first signs of CAN interfacing with my car. Here on my test instrument cluster you can see the instrument cluster showing agility mode on the gear display. A huge part of this CAN programming was writing the logic which signs the sent data sent from my TCM so that the engine's ECU is happy with what I am sending and does not think the data is corrupt. Should the engine think that data coming from my TCM is corrupt, it will enter limp home mode. I know that I'm glossing over a lot of what I actually did to achieve this. Don't worry, I'll soon be releasing a more technical video explaining sections of the codebase. If you're interested, stay tuned for that. Next, I set about writing the core gear shift logic of my gearbox. For testing purposes only, the car will be in full manual mode, meaning that only I can command gear changes from the flappy pedals of my steering wheel. There is currently no automatic logic. I spent about 4 hours writing the basic logic for this, and late one evening I finally enjoyed the results of this. This was the first gear shift my car did on my own TCM, and I was so happy to see this. Also, a minor convenience item I added was to allow for a PC style post beep on my TCM startup. This is basically an audible way for me to tell if the gearbox's code booted up okay or if errors were detected on startup.
So this is what a good gearbox sounds like. 2 little beeps, and if I do that again, you can see an S is displayed on here for sports profile. Now, if there was something wrong for transmission, and say for instance it was to power up and some of the checks on the processor were incorrect or it couldn't obtain CAN data, then this is what it will sound like. And on here you get an F, and wait for it. Oh, not this one. Transmission Consult Workshop, so it's clear that something is wrong with this gearbox.
All that was left now was for me to code the rest of the gear changes, actuating the gearbox's solenoids correctly to allow sequential shifting of gears. This took several more hours to achieve, and you shall see the result in present day me.
Now, with all that coding out the way, I thought it's finally time we put this in my car and see if it actually works. I should note that I currently know for a fact that there's no torque converter control and there's also no pressure regulation, so things might be a little bit harsh when shifting. On saying that, I thought I'd record my raw reactions to seeing if this works or not. So I'm excited, and let's go have a quick test. Alright, so it is finally time for the inaugural test of this. So I have my TCM plugged into the car. Stock one is over here in case things do get ugly. I'm going to be using this road over here to drive up and down and see how things shift. And my phone will be sat in this cradle here viewing the tachometer. So let's see how this goes. So for this first test we're in pure manual mode, so only I can change gears, the computers won't be able to using the flappy paddles. And let's floor it and see what happens. 3, 2, 1. This thing's shifting so quickly, oh my god. This is impressive. Okay, back down to 4th. Okay. 3rd. Now the only thing I'm noticing is going back down to 2nd, it seems there's some drag on the gearbox, so I need to work out what's causing that. Here we go, there's 2nd. It kind of is almost like the gearbox kind of locks up for a bit. Huh. I guess we'll need to increase shift pressure there. Yeah, it works. Let's have another go at it. Custom TCM take 2. Oh my god, this is so good.
Now, I could have ended the video here. However, I decided the next day I'll come back to my friend's workshop and try out my own TCM in his CL55 AMG from 2002. Now, due to it not being my own car, in the following clips I'm not flooring it like I was in my own car, just in case something did go wrong, but I think things did, so see for yourself.
So I have the original controller out, and let's put the new one in. Probably won't be able to film this whilst I'm doing this, hang on a second. So the new TCM is installed. You might be able to see some of the green tape on the edge there, which is proving my one there. And here's the original one from the car. So let's take this car out for a test drive. Okay, so here we go, let's go. Jeez, it's shifting so quickly. So take two if all the windows open, let's go. I actually can't believe this works, I'm so happy right now. So, I hope you enjoyed those two little test runs. Now, judging by how quickly the car was shifting using this controller, clearly shows that the 722.6 gearbox has quite a bit of shifting power, just Mercedes never harnessed it. So, I think we can try in the next part to see if we can get this controller to be a little bit smarter, so that it's not so jerky changing into gear, but at the same time it can give you a really, really quick shift if you want it, or a nice slow shift like in comfort mode if you really want. Other than that, if you liked the video, be sure to hit that like button and subscribe if you're new here. I appreciate new followers, and let me know in the comments what you want me to see to do to this, since basically as it's open source, sky's the limit as to what we can do with this gearbox. So let me know in the comments, and I'll see you in the next one. So bye for now.